So today we're going to go ahead and solve an AP Physics C free response problem, the first one from the 2022 AP exam. And again, this is from set 1. What I would encourage you to do is go to the AP Physics College Board website, go ahead and download this problem, try it yourself, and give yourself 15 minutes, which is how long you would get for this on an AP exam. And then you can check back on the video and watch how we solve it, and you can watch the rubric and see what the general breakdown of points is. Okay, so now that you've tried the problem yourself, let's go ahead and look at it together. So for number 1A, so great, we got to draw a free body diagram. So love a good free body diagram. So it's again for this mass, which I'm going to draw in here, this mass M. And it looks like, according to the picture, the motor is pulling on the string. So this motor is pulling on the string, pulling it down. So the object is moving to the left. Okay, so if we're drawing our free body diagram, we are going to have it's on a surface. So we're going to have Fn pushing up on it. Gravity, again, is always straight down. It's moving, the object is moving to the left, so friction has got to be to the right. And then tension, it is attached to a rope at about this angle right here, so that is force tension. Okay, so let's go ahead and go through the AP rubric for this one. So this one is out of 3 points. So for the point value for this, you get 1 point if you drew Fn and Fg correctly. You get 1 more point if you drew FF correctly. And then you get 1 point if you drew FT correctly. Okay, so for B, B is a tricky one. So we want to find an expression for the angle theta that the string makes with the horizontal as a function of x. So let's go ahead and look back at this picture. Okay, so we want to find something dealing with this angle theta. X is the distance it moves here. Okay, interesting. Let's look at what we know. And this is the height of it right there. Well, you know what? This looks more like kind of a math thing than a physics thing. It looks like a trig thing. So if we were to set this up on a picture, I'm going to go ahead and just draw this down there. We know that this distance on the bottom is just x. That angle is theta, and that is h. And no matter, like, even as the string angle changes, like, that's still going to be theta. The height is still theta, is h, and x changes. So that x will just change. If we wanted to find the hypotenuse, you can go ahead and think about what we do. Well, we could use the Pythagorean theorem, a squared plus b squared equals c squared. If we wanted to find the hypotenuse, let's just go ahead and write it on our thing. So h squared plus x squared equals, I'll say the hypotenuse squared. So that'll be then the square root of h squared plus x squared. Great. And I'll just put that on my picture. Okay. But anyways, we want to find the angle. Also, I'm going to just start with what we got to start. So we got the angle theta, we know side x, and we know side h. Okay, if I look at my trig identities, and I always write it down on my paper, so I have some good old SOHCAHTOA. This looks like we have opposite the angle, and adjacent from the angle, which is going to be tangent. So tangent of theta equals h over x. And if we want to solve for theta, then we got to use inverse tangent. So inverse tangent of h over x, and we got it. Great. So rubric for this one is 1 point just for recognizing, and it could be any expression that you're going to need to use, like sine, tangent, cosine, whatever it is. And then 1 point for an correct expression for theta. So this is out of 2 points. Okay, so now we want to go ahead and find normal force. So anytime I want to find a force, I'm going to always go back and look at my free body diagram. So again, this was my lovely free body diagram. So what I'm going to go ahead and do, I'm going to just redraw that below just so I have it as a reference right here. So again, we had Ft at an angle, we had Fn going up, gravity again is always straight down, and your gravity is mg, and then we have force of friction. Okay, so Fn is a force, and I'm going to say up and down direction is y, and horizontal direction is x. Fn is a y direction force. I'm going to look at my free body diagram and think, are there any forces that I need to split into the x and y components? Yes, there are. Ft, I'm going to have to split that into the x and y components. So this angle is going to be theta. So I'm going to go ahead and split that into, we'll have Ftx, which is just going to be what? Ft cosine of theta. And then we'll have Fty, which is just going to be Ft sine of theta. And we do our trig for that. I'm going to just redraw the free body diagram to the side, and this is what I do for thinking purposes. Again, the one in black is essentially our graded free body diagram. Don't change anything to that one on what you do for A. But now we can just do this for our own thinking purposes aside. So we have Fn, we have Ff, those are just x and y forces. Fg is just the y force, which is just mg. And then Ft, we have Fty, and then we have Ftx. Okay, so we want to find Fn, so we're going to have to look at the y direction. So let's go ahead and set up Fnet in the y direction. So Fnet y is going to be equal to Fty, which is going upwards, Fn, which is going upwards, and Fg, which is going down, so I'll say minus. Okay, let's think about what's happening in the y direction. It's not moving in the y direction, so Fnet y is going to be 0. Fty, again, we just wrote that, is going to be Ft sine of theta. Our goal is to find Fn, and Fg is just equal to mg. Okay, so we can go ahead and solve this for Fn. So I'm just going to say Fn equals, what is this going to be, mg minus Ft sine theta once I do a little manipulation. Okay, let's just go back to our original problem to see what's allowed in our final answer. So in our final answer, we're only allowed m, h, ftx, mu, k, l, and physical constants. So that would be like acceleration due to gravity, g. So we are not interested. Okay, and one little thing I noticed I did a silly mistake. They used little m, so I should be using little m instead of big M for the math. Okay, we're not allowed to have like theta in our final answer. So we got to figure out what theta is essentially equal to. Let's go ahead and go back to this triangle from the previous page. So this one right here that I went ahead and circled. So we know on this triangle, again, that's theta, that's x, that's h. This is h squared plus x squared. So we want to figure out what sine of theta again. Again, sine of theta is going to be opposite over hypotenuse. So let's go ahead and look at this triangle and see what opposite and hypotenuse is. So opposite is just going to be h, and hypotenuse is going to be h squared plus x squared. So that is just, we can go ahead and plug that in for sine of theta. So let's go ahead and do that right now. So we got Fn is equal to mg minus ft times h divided by square root of h squared plus x squared. Great, and voila, we got our final answer. Okay, let's go ahead and go through the rubric for this one. Okay, so this one is only out of 2 points. So you go ahead and you get 1 point for setting up Fnet y, and honestly, I would say that's the most important point. You also get 1 point for correctly identifying Fty, and that includes not having sine of theta in your final answer, but h divided by square root of h squared plus x squared. Honestly, I'd say that's like a pretty tricky one, so it's not the end of the world if you did not get that one, but really emphasize setting up Fnet y correctly. Okay, let's go ahead and look on to part. Okay, so now we want to find an expression for the magnitude of the net horizontal force exerted on the block as a function of position. Okay, so horizontal is the x direction. So let's go ahead and set up F net x. So what forces is F net x equal to? Well, let's go to our free body diagram. So now we're looking at the horizontal direction. So that's going to be Ftx minus Ff. Okay, so Ff, I don't think that was given as like an allowed thing in our answer. Neither was Ftx. So Ftx is going to be, so this is going to be what? Ft cosine of theta minus Ff, which is going to be mu Fn, and that is going to be F net x. Okay, Ft is allowed in our final answer, but cosine of theta is not in our final answer. So let's go ahead and go back to this triangle, again, where we know this is h, this is theta, this is x. So hypotenuse is square root of h squared plus x squared using Pythagorean theorem. So cosine of theta is going to be adjacent over hypotenuse. So that's going to be x over square root of h squared plus x squared. So we can go ahead and plug that in. So that's going to be ft times x divided by square root of h squared plus x squared. Okay, minus mu. Mu is a coefficient that's allowed in there. Let's see if they called it mu or if they called it mu k. What did they call it? They call it mu k. So kinetic friction we're talking about. And Fn. Fn is not allowed our final answer. So what can we plug in for Fn? Aha! We can plug in our answer from I. So that's going to be mg minus ft times, wow, this is a mess, h divided by square root of h squared plus x squared. Great, beautiful. Okay, so that is going to be our final answer. Let's go ahead and go through the rubric for that. Okay, So you get 1 point for correctly setting up FTX minus FF, so the correct force is in the x direction. You get another point for correctly putting down FTX, what FTX is, using your SOHCAHTOA and all that good stuff. And then you get 1 more point for substituting in for FM. And again, even if you did not get part I correct, but you substituted your answer from I, you would still get a point for that. So this one is added 3 points. Okay, on to the next. Okay, so now we need an integral expression for the work done by the string on the block. Okay, that's key as it moves from x equals L to x equals 0. So work is going to be the integral of the force with respect to distance. So the force we're talking about is the string force, but it's moving in the x direction. So we need to just deal with FTX because for work, we need the force and distance to be in the same direction or both like on the same like axis kind of thing. So both x or both y or whatever the axis is. We're going to have to integrate from x equals L to x equals 0. Now let's go ahead and just plug in what is FTX. So FTX, and we already found that, is going to be FT, we found this in our previous one, times x divided by square root of h squared plus x squared. And we will again integrate with respect to dx. Okay, so for this problem, you get 1 point. This is actually out of 3 points. You get 1 point for identifying that you need to use FTX, just the horizontal part of the force on the string. You get another point for correctly plugging in what FTX is. And then you get 1 last point for essentially writing the integral correctly with like the limits of integration, or you could write it with like a constant of integration as well. And so that's where your 3 points come from. Okay, so let's go ahead and look at this one. So if we look at this, so the amount of work as it moves from x equals L to x equals L over 2 compared to the very end. So when we first start, as it moves from, let's just go ahead and scroll here to here. So as it moves from, apologies. Okay, so it moves from L to L over 2. So comparing this distance to this distance at the very end. Okay, so when you get to like the end, the picture is going to look more like this. So it's kind of theta. So at the very end, FTX is going to be a lot smaller and FTY is going to be bigger. While at the beginning, because this angle is smaller, FTX is going to be a lot bigger and FTY is going to be smaller just because of like, the angle right there. Okay. So it's moving in the x direction. So since work is essentially force in the x direction times displacement, and again, we'd have to use the integral because the force is changing. But for work to be biggest, you need it to be like a bigger force in the x direction, which is going to be bigger during this beginning section than it is at the end section. So that means it's going to be more work is done. So that is going to be this for more work, and that is going to be 1 point. And then it is 1 point for the answer that we just discussed. And I ran ahead and wrote 1 point down as well for that one. Cool. So this was out of 15 points total. My general rule of thumb is that if you're getting around 9 to 15 points correctly, that's about an AP score of 5. If you're getting around 7 to 8 points, that's about an AP score of 4. If you are getting around 5 to 6 points, that is an AP score of a 3. If you get around 4 correct, that's an AP score of a 2. And if you get from 0 to 3 points, that's an AP score of 1. Again, that's my general rule of thumb. Not, it could be not exactly that, but you can use that to kind of guide you to see how you did on that one. Awesome. Well, thanks so much for watching and let me know if you have any questions.